Once upon a time, when I was about 12 or 13, my younger brother decided to invent his own numbering scheme. He called them triangular numbers. So a triangular number with a side of 0 was 0. A triangular number with a side of 1 was 1. A triangular number with a side of 2 was 3. Side of 3 is 6. Side of 4 is 10, and a side of 5 is 15, and so on and so forth. This is okay if you just draw it, but at the tender age of, I think, about 6th grade, he was able to figure out the formula. We take that side, multiply it by itself plus 1, and divide it by 2, and we come up with that number. So let's go back to my drawing of them. The visual logic for creating this design was a little complex. This is what it looks like. There's the formula that says that the triangular number is whatever I'm currently on. I was much older when I found out that some Greek mathematician figured this out way back a few thousand years ago. He was older than 12 when he did it. And we output the message about the size. When I was developing this, it took me a little bit to figure out that I had to have a loop within a loop within a loop to produce it. So feel free to try it out yourself. This isn't going to be our objective. Let's go back to the Excel. What my brother then found out was that if you add the current triangular number to the previous one, you get something special. So the current one plus the previous one. Let's copy the formula down. And we find out that the sum of two consecutive triangular numbers is a square. Now, truth be told, he then went to three-dimensional numbers, and he went to pentagonal numbers, and somewhere along the line he decided this was getting too hard and gave up and just did regular algebra. We're going to stop here. In the next video, we will turn this algorithm into a visual logic flowchart and see what we'd need to do to add the current one to the previous one, the steps we'd have to take. See you in a bit.